So for the metal ammonia reduction of alkynes to transalkenes, our reactant will be an alkyne, and so you have NaNH3 as the reagent, and it'll cause it to become a transalkene. So, and then the final thing, sterics cause the product to be trans. So you have your alkyne, right? And so I put these red dots to represent the electrons, because that's what it truly is, two electrons being shared in this bond. So what happens is in this solution with this reagent, you have your electrons, right? And since it's just one electron, it's going to be a half arrow. The half arrow comes and attacks this carbon right here. So it wants to be there. So what happens is this entire bond, that's why this is a full arrow, this entire bond goes to this carbon. So it'll be a negative charge here, making it a carb anion, and the carbon radical right there. So this anion will come by and attack the NH3, and it'll attack a hydrogen, right? Because it wants to get rid of the negative charge. So when it does that, it forms a bond with hydrogen, right? Because now you see that the two negative electrons right here, they'll be form a bond between the hydrogen, so that's taken care of. And now the other electron, right, will come by and attack this radical right here. So in that case, it'll form a negative charge, right, because it's a carbanion now. And this carbanion will attack another hydrogen, form a bond with hydrogen, and therefore the final product will be a transalkene. And you can write it either way, but usually the hydrogens are implied, so you can just take that away. And then so you have a transalkene, right, because you have a double bond here, and it's trans. So that's the entire mechanism. And so you'd represent that by just showing this, an alkyne, NaNH3, and then it becomes a transalkene. So I hope that helped, and thanks for watching.